Today, we're going to talk about RPKI. The goal is to give you an overview of how RPKI is, what's needed to set up your ROAS, your validation, the two different parts that compose RPKI. And then together with Tön, we will be looking at one of the tools we can use to verify the data that's provided by your organization, by yourself, or by other organizations. Looking into ROAS, route objects, BGP announcements, and a little bit more. So I will take the lead for the moment, and I'll start sharing my slides. So we're here to introduce RPKI, and the way it is composed, it's we have a small introduction. We will talk about ROAS, and I will do a demo on how to create these ROAS. Then right after that, I'll hand it over for a while to Tön. So actually, I will create some real ROAS in the database. So maybe Tön can show you how to check that what I've done is right. Some of them, I have different networks, so I won't touch one of them, so we can verify that, and the others we will do the check. And then we will go into deploying RPKI validators. So how they run, what they are. I have a very brief demo because setting them up is really straightforward. And then we will talk about validation, including a demo where we set up BGP origin validation, and then I'll show you how to discard BGP invalids. It's actually one single demo, but it includes both versions. And then I have the future of RPKI, but we won't go into this in such a short time frame. But this is part of what you might see during the week later on. So before we start, we have to understand what problems we have on the internet nowadays related to BGP. And the main one is, once we have two networks, we have network A and network B in this example. When they start talking BGP between each other to make BGP announcements, to make sure that their IP addresses are reachable from the internet and can reach the rest of the internet, they use a protocol, BGP, that was designed to be, at least at the beginning, really simple. So you set up a BGP session, and from network B, you say, these are my IP addresses. I have this network, 213, XXXX. That's not important in detail. Network A takes that information, creates an entry in its routing table, which says, if you want to reach those addresses, we have to talk to network B. And the same happens in the other sense. A makes an announcement, what's called the BGP announcement, and tells B, this is my network, 193.xxx. But then there is a problem. The protocol itself, BGP, doesn't have any way to let us understand if these claims, there are two claims in this slide for the moment. Two networks are being claimed to be operated by two prefixes are claimed to be operated by two different networks. How do we verify that? The problem is we need a way to figure out if the claim made, say, by both network A and network B are real, are valid. So we have to figure out if there can be trust, and from both sides. So far, this has been a long-standing issue. We've used, for example, the RIPE database, an internet routing registry. It's a database where we store information in the form of objects. And we have objects that help us understand if we can trust a BGP announcement. So they tell us there are objects that tell us 213.xxx should be seen as announced by network B. And then network A can query this RIPE database the same way he or she can query the LACNIC database, where the AFRINIC, APNIC, and ARIN, IRR, and some other IRRs. We'll get to that in a moment. But with a query, you can verify in a certain way and know that the data you've seen in BGP can sort of be trusted. There's not a full 100% trust, but you can have a certain degree of trust in there. Now, there is also a problem related to the Internet Routing Registry. That is, some of its data cannot be fully trusted for accuracy, for incomplete data, or lack of maintenance. For in the course of the week, you will see me, if you really follow, I will be presenting about a couple of tools that we've been working on. And I can tell you the story of when I was developing one of the features of these tools. And I've asked a colleague, can I need to come up with a small country with a small number of prefixes to run my tool against and verify that it's working. And so the suggestion came with Mauritius, because the colleague was from Mauritius. And I spent 2 days trying to debug my application, which seemed to not be working because no route object could be validated from any network in Mauritius. And then turns out that, well, apparently many of the networks in Mauritius all of them didn't create entries in the AFRINIC database for the networks that were actually instead, that had root objects in the RIPE registry before. Now, RIPE has created a different, what's called a source. So they are flagged to not be maintained. So there's a different source that's called RIPE non-authoritative, RIPE non-auth. And turns out that all those objects covering those networks were in the non-authoritative database, part of the database. So that showed an incredible lack of maintenance. But these networks are being announced on the internet and they just work. People can browse the internet from them and everything works. But this is a clear example of, okay, there's lack of maintenance, but we can manually override that and who cares? And then there's a series of third-party databases because for example, the ARIN IRR is relatively new. In LACNIC, the IRR is also relatively new. So in those regions, you had to create your entries in a third-party database. And the problem of a third-party database, differently from RIPE-NCC or APNIC, who run both the RIPE database, the APNIC database, and they can verify you're the legitimate holder of a certain range of IP addresses or ASNs. A third party has a much harder time doing that. So there are different levels of verification depending on which database you're using. But RADB, AltDB, these so-called third-party databases, again, have a real hard time validating who operates, who is the legitimate holder of IP addresses and autonomous system numbers. So to solve these problems, to build on top of what we had, RPKI came up in 2008. It came out of an ITF standardization track, and of course, community-driven. But the idea was, let's take what we have. Let's take the concepts we have now. We have root objects. We move root objects to be signed so we can trust where they come from. If we can verify the signature, if we can verify the certificates associated with them. And with these, we get data that we finally can trust. So the idea was to take what we had, take the concepts, make it more trustable, and make it so that it follows the chain of trust of the regional registries. And we'll see that in a moment. So we have certificates that have been generated by all the 5 regional registries that sign that basically cover all the resources, 0/0. In the past, it wasn't like this. In the past, the regional registries created specific certificates for the delegations that they received, for the allocations that they had received from IANA. But given now there's a, well, not everywhere, but in many of the regional registries, you're allowed to transfer addresses between them. Regional registries now need to cover all the address space because they don't know what might be transferred into them or out of them. So we have this certificate created by the regional registries, and then for every member in the RIPE region, they're called LARs, but let's call them members. They have their own also certificate authority, their own certificate that's then signed by the root certificate from the regional registry. So this way, we start creating this chain of trust that can tell us, if we look at a certificate from a member, we can tell if it validates or not. Maybe it might have been revoked because they didn't pay for their yearly membership. We can figure it out very quickly by verifying the chain of trust. So we have an easier way to understand how things really are in relationship to the address space. Now, we get this. We get RPKI, which helps us tie, as we did in the RIPE database or previous IRRs, we tie IP addresses and autonomous system numbers. So we have these two parts of data, but we also tie them to public keys. So we add something on top of what we had. Following the hierarchy of the registries, so we make it so that we can easily associate with each and every one of the registries. None of them were excluded. And then gives us statements. So it gives us what we had already before in terms of root objects. So a certain ASN should be seen originating, announcing this prefix. But as said on the slide, now we have a signature that helps us figure out, oh, who signed this? Who signed this piece? Can we trust this person? Can we trust this entity? And then we can walk the chain of trust to figure this out. So the piece of information that we're looking at most of the time in RPKI are ROAs. But before we look at ROAs, we have to look at how RPKI is structured. If you've ever seen DNSSEC, some of you have, I'm pretty sure, have knowledge in DNS. It's relatively the same thing. We have a part where we sign something, we provide information. So that's where we get our ROAs. And then we have a totally separate process. That's the validation, where we verify what others have put into the system in terms of ROAs. And you see there's a very clear division between the two parts, because you could be signing your ROAs without validating. They're two totally separate parts. And vice versa, you could be validating without having signed your ROAs for reasons we don't know. I see a question in the chat. 1 second. Is the root certificate created and self-signed by the 5 RIRs, or is the root certificate created by IANA? This is a very good question. So the five RIRs have different certificates. No, there isn't one created by IANA. IANA is out of the equation here. I'm not sure this is a very good statement to say, but in the sense, like, IANA didn't do anything at the moment so far. But we'll see when we talk about the validation. I'll show you that there is what's called a trust anchor locator. So there's a file for each one of the regional registries that includes a pointer to where all the ROAs, all the certificates all the keys can be found. Well, public. keys, not the private ones. And there's also a the public key for the top. And those are distributed as files with all the validators, with all the software. There's a small exception, but I'll talk about it later. Let's not get into that now. I hope I answered your question, Sergio. Okay, perfect. But there will be more. Let's not step ahead of where we are. Let's look at ROAS, and then I'll get back to you as well when we talk instead about the validation. So we have two separate processes. We have signature and validation. Let's start looking at the signature, because that's the easiest way. That's the easiest part. Basically, we have a ROA that stands for, I always get confused, but it's written later. Route origin authorization. Let's go back here. It's a statement. It's a file that contains basically the prefix and the origin, similar to a route object. It's the same exact type of information. And it gives us which ASN is authorized to announce a certain prefix. But a ROA is a bit enhanced from a route object. Well, route objects can exist in multiple types for the same prefix with different origin. And there's a keyword that we're introducing here, max length. We'll see that in a moment. And ROAs can overlap. So you can create ROAs the way you want. You can have multiple ROAs for the same prefix with different origin. You can have multiple ROAs with different max length. They can overlap. You can have a ROA for a /22 for one of the /23s covered by this /22 and so on. So you have complete freedom on how you can create a ROA. And what does it contain? It contains a prefix we've already mentioned, an origin ASN. So far, this is exactly the same as a root object. But while they were creating RPKI, they decided to add something that could help you if you have a large network, if you have the need to make different types of announcements. So the maximum length, max length. Normally, you would have a prefix which contains the in slash notation, the prefix itself, and then you have the max length that express from where to where, basically, it can go. But let's look at an example to show you what max length is. Let's assume we have a network that has max length /24. So we have this /22, max length /24. It means that in this case, we could announce the /22, we could announce the separate /23s, and also all the separate /24s, all contained under this /22. If we go something more specific, forget the fact that the /25 would be filtered in other ways. But the /25s, in this case, they would not be covered by this ROA. They would come up as, we'll see that later, as invalid. But so far, you just have to know the ROA wouldn't cover them. So another example, we have this /21 with AS2121 as origin, and max length is /21. So basically, this covers just the /21 and nothing more specific. So everything, oops, let me do, okay, this, I pushed too many times the keyboard. So we have the /21, and anything more specific from the /22s below, not covered. So, well, covered, but max length doesn't allow for them. So if you see such an announcement, you should be, in theory, filtering it out. But then let's say one day you want to change your behavior and you want to announce something different. You can create a more specific ROA for this specific /23 saying max length up to /24. So you would change the status to make it like this. Same thing, you can do it with another part of the address space. You have a /23, AS2121, max length /23. So you go and change the status of just one of these BGP announcements. So far, so good. I don't see any questions in the chat. Feel free to also, now that we almost just started, raise your hand, ask the question via voice or anything. I'm more than happy to answer any question you can come up with related to RPKI. But with such a flexibility in max length, we have, oh, here a question before I start the slide. Is there a best practice? Here we go. This is a good question. Is there a best practice or guideline document on how to create ROAs with prefixes? Okay, this slide and the next one is going to show you what a drawback could be from using max length. And then at the end of these two slides, I will give you a short guideline because there is a draft RFC that explains this and gives also short suggestions on how to create your ROAs. So stay with me for a moment for the next two slides, and I will answer your question. So you created a single ROA authorizing the entire /22 with a max length of /24. So imagine you have this /23, perfectly acceptable. You have someone, though, one day, you're only announcing the /23. You have someone one day that decides they want to mess up with your network. It's a relatively simple procedure. Imagine this someone runs a data center or has access to a BGP speaker. Could take your ASN, add your ASN to their AS set, basically claiming that you are a customer behind them, wait a few days, and then set up a BGP router behind their router that uses your ASN and announces that specific /24. At this point, you would have someone announcing maliciously a /24 with your ASN as origin. Behind their ASN, so the filters, because they added you to their AS set, the filters have been cleared, everything's fine. Basically, that would show up as valid. That's /24. That's a malicious announcement, which RPKI cannot distinguish from another one in this sense, because RPKI only looks at the origin, and it doesn't look at the AS path. There are technologies to check the AS path. They're not really there yet in different ways. But so far, let's focus on this. The origination shows up as correct. Your ASN is announcing that /24. RPKI cannot do anything. So here's a suggestion. Create ROAs for your BGP announcements only. Consider them the same way you would consider route objects, because the same trick works with route objects. If you create too many route objects that are too open, you are going to have the same exact issue. In this case, /22 with a max length of /23, if you have the same malicious attacker that tries to run the same kind of attack, that will show up as invalid because the ROA only covers up to /23. Now, there are some considerations to make here. So the main suggestion is to follow what you have in the root objects. Follow what you have now in your specific BGP announcements. Don't allow too much. This comes at the cost of flexibility. The moment you want to allow a new network to be announced, RPKI is not as immediate as route objects. Route objects, you would go on the database, You would create a new route object, it would show up immediately. Or well, with a delay of maybe 15, 20 seconds, depending on the synchronization of the different servers. With RPKI, you create a ROA, and it might take some time before it shows up. Say 20 minutes, half an hour. There is a, I haven't checked if a colleague is on the tutorial. If Amrish is on the tutorial, maybe he could say something more about that. But yes, Amrish, you're here.
Yeah.
Yes, you've run a study together with other people.
Yes.
And what was the result? What's the average time it takes for a ROA to show up once it was created?
Yeah, so it depends on the action. So whether it is a creation, so hello everybody. My name is Amrish. I'm a colleague of Max. We do a few things together. Yeah, so we did a study recently on how much time it takes when you create a ROA and at what point in time you see the change in BGP. And what we saw is it depends on whether it is a creation or a deletion of a ROA. And creation, it would take, it can take as low as 10 minutes, because in some RIOs, for example, Epinik, they do have like a batch processing that they do every 10 minutes. So it can take 10 minutes plus a few minutes for it to appear on the BGP. That's the best case. But it also depending on the ISP, the type of the router they're using, so the default settings that they have. And on top of that, you also have the cache validator, which also has a refresh time. So it can take up to 1 hour in some cases for the change to appear in BGP.
So imagine you are in a hurry,
yeah,
but then it takes an hour for the ROA to show up.
Yeah, this can sometimes be a problem. Let's say you're facing a DDoS, you want to create ROAs speedily, and then you have to wait an hour. So on the revocation side, if I may, Max.
Go ahead. Sorry.
It might take sometimes more time. This is what we have observed, because what we are suspecting is that in some cases, some BGP speakers, they would be connected to not only one cache validator, they might be connected to a few cache validators, because sometimes you have this kind of setup for redundancy. And depending on the state of the cache validator, some might be up to date, but some might have a refresh time which is much bigger, and then so they refresh at a later time. So the validity of the ROA will take the one it has, the positive response it is getting from any of those validators. So even if on one it is up to date, it will always take the one which is positive on one of the validators. So this can take a bit of time, and therefore what we have seen generally is revocation takes much longer than creation of a ROA.
Right. Thank you, Amrish.
Yeah.
So stay online if I have any other questions about this timing. But so as you've seen, thank you. As you've seen, the suggestion is to be strict, but consider also the option of preparing yourself in case you want to announce something more specific, or you want to change something in your announcements. Don't forget, especially when you want to change or move or do something, that ROAs can overlap. And so you can have ROAs with different origins. You can prepare for a migration times in advance. So you have great flexibility, but you also have to keep in mind with flexibility, some drawbacks might appear. And one of them is the one that we showed you here. There is a draft discussing this issue. I will look it up while Tern speaks later. So The ROA is an object that contains this data and gets signed as well by the members, by the LIR. So then it becomes part of the full chain of trust. So we can start from the ROA, look, figure out who signed it, check the signature, verify the CA from the member, and then verify that it was signed and that there's no revocation from the top, from the regional registry. So, Patrick, have we answered your question? I know this is not a full set of best practices, but there isn't that much else we can say. So the general rule is to try to follow route objects, or try to make the best compromise between being strict and have enough flexibility so that when you know you will need to change things, you have it, and you have it immediately. Or live with the fact that when you make a change in ROAS, it might take up to an hour for it to propagate. So this is the most I can say, at least that I've seen around. But I see Tern is nodding. I think that's the most we can tell you at the moment. Yeah. Okay. So I mentioned that one of the pluses of running RPKI is that, differently from the IRR, the Internet Routing Registry, or not differently, there was a different start. There was a way at the point when RPKI was developed as a concept to say, well, we want everyone, we want all the regional registries to be on board, and we want to follow the hierarchy. So we have the anchors that are at the registries, and then we have members who depend directly from there. Okay, so the answer from Patrick is be strict or follow the route objects is a good guideline, thank you. With the ability to create a /16 up to /24 versus exactly what you announce and no guidelines, this was why I was wondering. Okay, good. And then Tern replying, what we typically do is create ROAS only for the exact prefix and for the /24. So we can reroute a /24 via the DDoS scrubbing network. That's also a good suggestion, because there have been different discussions about what to do in case of DDoS, because you want the scrubbing system to start working very soon. But then if you have to wait for the propagation of route objects, ROAS, it might take a long time. So what you want to do is maybe follow Tern's suggestion to also create the entries for /24s. But then I'll show you there's a tool you can use to figure out if someone else is announcing your prefixes, and we'll see it at the end. And I don't think I've seen the author on the call today. No, not yet. So we go back to the RPKI certificate structure. We follow the hierarchy of allocation. And we have, similar to what we've seen in the previous slide with the chain of trust, here we have the IRR, we have the member, we have the ROA, same exact one, very simple. And then we have either hosted or delegated RPKI. And this is a long-standing discussion, people who love delegated, people who love hosted. There's no one size fits all, and it's up to you to decide which one you prefer. But what does it mean? What does it mean when we say hosted or delegated? When we say hosted, it means that the RIPE-NCC, or, well, this is the example I have here, but the RIPE-NCC or ARIN, APNIC, your local regional registry runs everything for you. So in the case of RIPE-NCC, we'll see that there's a web interface. The RIPE-NCC creates the CA for you. You just have to push a button, And then there's a very easy to use interface to create and delete ROAs, to change them, do everything you need. But this is easy when you have a very small number of networks in just one regional registry, like my case. I have my own ASN, but I have 3 networks. I have 2 IPv6 and 1 IPv4. So in my case, which is very, very simple, hosted works perfectly, because then I don't have to deal with anything. I just go create, push a button. RPCC does everything for me behind the curtain and does the key rollovers. The signing is automated. Everything's fine. So I just have to focus on creating and publishing my roles. Okay, so there's a suggestion from Mohammed, going back to one slide. In that scenario, would autonomous object help us in specifying the import and export policy? It would help, but unfortunately, not many tools or not many networks look at the policies in the autonomous object. So I always suggest people to keep them updated when possible. But at the same time, consider that there's a very, very low number of networks actually looking at those at that data. So if you can, keep them updated, but I wouldn't trust the fact that other people will look at them. So route objects, 99.9%, you can say they will trust the route objects. ROAs, 99.9%. I always keep that 0.1% because you never know. But I would say you have very, very good chances that route objects will be looked at, will be considered. Same for ROAs. But when it's about import and export policies in autonomous objects, I wouldn't really trust that, unfortunately. So getting back to our hosted RPKI, very simple, especially at RIPE. I go and create my ROAs, go and push a button, the CA gets created for me. No key rollovers to take care of, everything's done by the original registry. Same situation you have on the other RIRs with different levels of automation or simplicity. In ARIN, you have to generate your keys yourself and then upload them. I'm not sure about Afrinic, but in basically most of the cases, you have a simple life. So there's not that much you need to do. But if your use case is a bit more complex, let's say you have resources, so networks from 2, 3 different RIRs, and you don't want to go in and change things manually on all of them, you could run delegated RPKI, where you run your own software, where you run your own CA, you set up, of course, here we say a connection with the CA from your original registry, where they sign your the top of your local CA. So you create a relationship between the two. And then you create your own objects. Then there's another issue. You have to publish these objects. So there are different solutions. One is to run your own rsync server, run your own RDAP software. RDAP basically is a protocol that uses HTTP, HTTPS as a base and distributes ROAs using HTTPS, basically. Or some RIRs, now ARIN, I know RPCC is working on it. You can so you have your own software running on your own hardware, you generate your ROAs, you sign them, and then you're given a way to publish those ROAs at your parent, so at your RIR, so that there are not so many distributed endpoints to look at in the world. Because whenever you will see your validator runs, it has to download all the ROAs from all the publication points in the world. If we restrict the number of these publication points, it should be better for everyone. So we don't end up with 70,000 different HTTPS hosts we have to contact every time we want to update our ROA repository. That would still work, but maybe not recommended. But if you have some, personally, I would suggest if you have a very special use case, run delegated RPKI. Otherwise, if you don't do much with your ROAs, you don't change your route objects already every week or so, I would suggest go with a hosted solution, because that's the best one. At RIPE, you can also certify PI resources, but there's a specific procedure you have to follow, but you can do that. But then that's very specific for the RIPE region. I left it there because it shows that they have thought about everything. And then here we have a demo on creating ROAs. So let me stop sharing the slides. I'll share my screen from the LAR portal. Here we go. So here I am, LAR portal. Let me make the text a bit bigger so you can see the 100%. Here we go. I will sign in with RIPE NCC access. And of course, there's a disclaimer. I can show you how things are in RIPE. In Afrinic, in APNIC, in other registries, things are a bit different, but I don't have access to all of them. I have my own LAR in RIPE, and this is what I can show you. So I've logged into the LAR portal. I go into my RPKI dashboard, and what I'm greeted with is I have 2 BGP announcements that are seen. I told you I have 3 networks, but we'll get to that in a moment. And then it says there's an origin ASN. Let me make the text a bit bigger, because I think, okay. You see that I have an ASN that's originating them. There's a prefix, a /29, and a /22 IPv4. And these are current status valid. So I can go and check what ROAs do I have. I actually have more than those. I have an additional ROA for this 2A0F column FD00/29, but there is no affected announcement here. So this is a way where I can show you how helpful the interface here is. It shows me that I have a ROA, but it doesn't affect any BGP announcement because I'm not announcing the /29 IPv6 yet. And then there is a ROA as another example where I actually, let me delete it. Okay, I want to delete it. I check and review the changes. There's no affected announcement. I can say go and apply the change. Voila, so the ROA is gone. And let me show you how I create a new one. AS number 141384. This is the ISOC. We have a small network we run at ISOC just for a bit of research. I can pick one prefix from the ones I have, a /24, and here I supply, I will need to close the windows in a moment. I can say, let's go up to /27, max length, just because I can. Here we are. The system tells me this is a new one. It got staged, so I could create it for now. I can apply the change or discard it. I can go ahead and just apply them. And here we are, my ROA has been created. That's really easy. And also, as easy would be to revoke the hosted CA. One day I want to change and run my own Krill instance, run my own Dragon Research RPKI.net system. I could just revoke my hosted CA and start again from scratch and go through the procedure to create my own CA. Oh, and as you can see, I created the ROA in 30 seconds, and consider what we have here. We have a ROA for this /22. Later on during the exercises, we'll actually use this ROA to do origin validation. So far, so good. I'll stop sharing so I can have a look maybe at the questions. We don't have any other question. Oh, we have. If you make an entry for a /16 with max length of /24, so there would be one ROA. If you make an entry for the same prefix but covering, well, that would be, yes, that's correct. Although it wouldn't be the same prefix, but it would be each one of the /24s under that /16. It would be exactly the same in the end. If you have if you create a ROA that says 16 max length 24, but then you create all the more specific /24s, you're not adding anything because they would be already valid. You would just end up with plenty of with 256 other objects. It would be pretty much the same, although with the max length you would cover anything in between. So /18, /19, 20, 21, 22. So in this case, it's up to you and how you want to prepare your ROAs for your coming BGP announcements. Does it make sense? Okay, perfect. Thanks. Okay, so I stopped sharing and now I'll hand it over to Teun because we have created ROAs and we have ROAs. And then if you want to check what you have done and when it shows up in the world, when it becomes visible, you can use a tool that Teun will show you in a moment.
Yeah, right. So hi everyone. Let me start sharing my screen then. Let's see. This should be visible for you right now, I hope.
Yes, it is. Perfect.
Okay, great. So I think I will skip through a few of my slides because Max already told you some things about them, but here we go. Right. So short thing about NLNOC, we're the Dutch Network Operator Group. We're celebrating our 20th anniversary this year, which will be with a live event on September the 30th in Amsterdam. We're totally community driven and we do a lot of cool stuff like the NLNOC ring. We have Looking Glass, we have IRR Explorer, which I'm presenting about right now. And well, the event I told you about, the yearly NLNOC Day. So I'm Teun Vink. I'm one of the AL board members. In my day job, I'm the senior network engineer or the tech team lead for BIT, a reasonably small Dutch ISP and data center. I have implemented RPKI validation in my network. I crashed RPDs, triggered some funky DDoS bug, which caused our routers to crash. But we're all good now after some upgrades. So, right. So this is basically what Max already told you. We need to filter routes. RPKI is helpful, but it's not everything. You only have origin validation. You don't have path validation, for example, and also not everyone is using it yet. And route objects in the IRR database help, but as Max explained, there are many IRR databases. There are conflicting information, and some databases are very complex to get data removed from. So, yeah, how do you deal with that? Well, and how do you deal with the fact that you have all this information and you have no idea where to look? And now that's where IRR Explorer comes in. IRR Explorer is both a web page and a tool which you can host yourself. I wouldn't really recommend it, but you can do it, which shows for a prefix or a number of prefixes an overview of all the IRR database registrations, of the RPKI ROAs, of all routing table entries we can find. And we try to, well, present it in a useful format so you have suggestions on how you can improve these either ROAS or route objects or whatever it runs into, and it points out conflicts. And this helps you reach two things: better reachability of prefixes, because you can find out that there is a ROA missing, which prevents others from accepting your prefix probably. It helps clean up the IRR databases, because it will show you that there can be a lot of mess there. And in this presentation, I will be mostly showing you some output of the IRR Explorer tool. So you can find IRR Explorer at irrexplorer.nlog.net. And this is basically the main page. It's not much, it's just a form with one field, and you can fill in either a prefix, an AS number, or an AS set name. And for each of the three, it basically does the same. It goes and look up all this information and show you what it can find about it. In my examples, I only use specific prefixes to keep it, well, simple and condensed. For ASNs and AS sets, it basically works the same. It's just more prefixes at the same time. Well, let's take a look what happens if you enter a prefix in IRR Explorer. I picked the RPKI routing beacon, which is a known good prefix, which has a valid ROA. And here this is what you see when you just enter the prefix and push submit. You see a table showing you a report for this specific prefix, and well, the green shows clearly everything is good. We see, and I'll show the columns in detail in the next slide, a number of things about this prefix. It combines the rear data, who is assigning or allocating the IP space. It shows what's happening in BGP, in RPKI, and what is in the various IRR databases. So if you look at that, the columns of the table, you see just as I explained, the prefix is found in one of the sources. In later examples, you will see that for one prefix, you can see more than one output. So you see more than one rows of data. This shows in a pretty condensed way everything we can find. The right column, in this case, shows that this specific prefix is found in the right database. If there is a route object in another database, for example, in LDB or RADB, you see more than one column, one for each individual IRR. Few hints on the output. Well, you can expand the help text at the top of the screen, and they explain in more detail what the results you can see mean. So what does a specific error message or warning mean? Well, the row colors are obviously significant. Now we saw only green. In later examples, we will see yellow and red, for example, to show possible issues or plain errors. Many of the output items are clickable, and you can see either who is information or database information or routing table info. So you can see what exactly IRR Explorer found about a specific prefix. In some cases, you see icons next to an AS number, and they have a meaning. The check mark means something is okay. The cross means it's not. And if you hover over it, you'll see more info. And we've now seen only HTML output, nicely rendered web table. There's a link for the JSON output as well. So if you want to, you can use that and process it in any way you like. So now look at another prefix. This is also from RPKI. This is a known bad routing beacon. And you obviously see the red colors here. There are two issues, and you see two pieces of advice there. The first issue is that RPKI origin does not match the BGP origin. Well, as Max explained, you can create a ROA. In this case, the ROA tells us that AS196615 can announce this specific prefix. But the BGP table shows us that AS12654 is announcing it. That doesn't match. And of course, you would expect either a ROA to be available for 12654, or you would expect a route in the routing tables for the 196615 ASN. And the second issue is that there are RPKI invalid routes found. The route object in RIPE has an RPKI invalid origin ASN. So the RIPE column shows us that there is a route object for 12654, sorry, while RPKI tells us it should be 196615. And only one of those two can be correct. You can't, because if you would start, well, 12654 cannot advertise this prefix as it is because RPKI tells us it's not correct. So there should be a route object for 196615. Or once again, you could delete the ROA for 196615. As you see, there is not one way you can solve this, and the way to solve it is mostly up to you, because you should know the way your network is behaving. This is not something IRR Explorer can tell you, but it can point out there's a conflict here. These two things do not match. How to solve it, that should be up to you. Up to now, we only saw one output column or table, and it's the exact prefix matches. Sometimes it's possible that there are routes or objects found, prefixes found in one of the databases, routing tables, or the ROAs that cover more than just that one prefix you asked about. And in that case, IRR Explorer will not just show you the exact match for what you asked, but also for the least specific match of what it found, everything it can tell you about that as well. So that can be helpful if you want to look at the broader scope of what's happening with a prefix. If you look at what we're seeing here, you see that this is one of the Cloudflare prefixes, it seems. And there for the /20, there is a good ROA. Everything is fine. For the /12, they don't seem to have created a ROA. But in the second table, you see that they did create ROAs for every /20. So you could wonder, why is that /12 in BGP without a ROA? Cloudflare may have good reasons for them. I can't tell. Well, let's look at some more errors that we can find. I was curious about the 1.1.1. That's one, actually, the Cloudflare DNS IP. And one of the fascinating things you see is that there are, well, a number of entries that don't match here. The first row in the table shows us what we would expect. Everything looks good. There's the /22, or sorry, the /24 is announced. It has an RPKI valid ROA, and it's registered in AP NIC. That's fine. But then we find two other prefixes, which are /32s, registered in RADB. And yeah, well, they are curious, of course, because they are registered by two different ASNs, not Cloudflare, but I haven't written down which one they are. But yeah, they obviously shouldn't be here. In fact, those route objects are RPKI invalid if you would announce it like that. IRRs will also spot that this object is in RADB, even though you would expect an object in the APNIC database, because APNIC allocated this IP space to Cloudflare. And the last notice, which is actually a good thing in this case, is that although there are this prefix has route objects, these /32s, we don't see them in the DS set. They are not actually seen in any routing tables, luckily. Of course, the good thing here would be that these /32s would be deleted. I'm not sure if Cloudflare has attempted to get that done. I also have no idea why these specific /32s are in the database. They don't make much sense. Okay, now there are some more fascinating things to see. One of the prefixes I tested when looking for, well, funny things to show was the Teredo prefix. Teredo used to be the IPv6 tunnel broker for people who didn't have native IPv6, and Teredo was anycasted by a lot of different ASNs. So you could host your own Teredo server, register a route object, so you could start advertising the Teredo IPv6 space, and you were all good to go. You see a number of things here. For example, you see that there are a lot of route objects in various route databases like AltDB, NTT.com, and the route non-authoritative database. It's like 15 altogether or something. Even though the BGP column shows us that only 2 networks are actively advertising this prefix. And we also see another thing, it's the red error message. There are no route objects that match the DSZ origin, and that's for the AS6939 Hurricane Electric network. They didn't create an IRR object. And of course, you see here, especially, that there's a lot of old entries that should have been deleted long ago. So what can you do with IRR Explorer? You can improve the routability of your prefixes. You can do that by, well, checking periodically. What do you see when you enter your prefixes? Do you see any issues? Any, well, especially the red notifications should stand out, and you should probably investigate. But you can do housekeeping on your IRR database entries, because it can point out old things that shouldn't be there, especially if you didn't create them, but someone else created objects which relate to your IP space in another database, like we saw for the 1.1.1.0/24 prefix. You can help it to analyze routing problems. Why isn't my prefix advertised to some specific other network, or why can't I see a better route towards that network? It could be that RPKI is one of the is causing one of the problems there, and getting the information there really helps. This is the one I use it mostly for. If a customer comes to me and says, "Hey, would you start advertising my IP space? Please transfer it to your network or to your ASN." IRR Explorer really helps you to check, are there any RPKI entries I need to get rid of, or should I add them? Are there route objects which can be a problem? Is the prefix advertised at this moment? All these things is IRR Explorer able to tell you. And of course, monitoring your prefixes, just checking if everything is still okay, if you need to do any changes. Especially the JSON output helps here, if you can automate it in any way. One very important thing to keep in mind is that IRR Explorer is an opinion on the information we can find. It's based on best current practices for routing, but it can be very well that you have a good reason to do something that IRR Explorer well, claims is incorrect, or shows a warning. It is not the absolute truth. It's just an opinion, and I think we're right in many times, but there may be reasons you do things differently. So IRR Explorer was developed and maintained, and that was mostly by help with from the RPKI Community Fund and ISOC, and we really like to thank them for that, because without that it wouldn't be possible to maintain this tool. So if you have any questions on IRR Explorer, if you'd like to check the source code or open an issue, feel free to contact us by mail or open an issue on the issue tracker if you have a suggestion how to improve it, or if you see something wrong, which can of course also happen. Please contact us. Okay. Yeah.
I haven't seen any questions so far.
Okay.
I think maybe the questions will come later.
Who knows?
Or who knows?
It's
well, for the moment, yes. It's I understand it might be a lot to take in.
Yeah.
But thank you, Teun. I will go back to the presentation, and then if any of you have any question, any remaining question about IRR Explorer, feel free to put it in the chat, and then I can answer. I don't know if Teun has time to stay with us also now that you've finished presenting, but feel free to ask any questions here, and we'll do the best to answer them.
I'll try to stay.
Yeah. Thank you very much. Okay, let me get back to the presentation now, because we basically now look at the same type of sort of the same type of data that we can see. Well, it is the same data we see in IRR Explorer, but let's say we have software that is supposed to be doing that work for us. So we look at the other side of RPKI, from the signature, from generating data, we move over to verifying how this data is. And when we look at this, we encounter software that are called RPKI validators. These are software that create what's called a local validated cache with all the valid rows, which at that point change name and they become VRPs, but I still like to call them ROAs all the way. I know Amrish doesn't like this. I know Amrish likes to be more specific, but because Amrish used to work on the RPKI repository at Afrinic, but let's keep calling them ROAs for the moment. Let's not make things more complicated for the moment. So an RPKI validator is a software that, whose goal is to download all the RPKI repositories from the RIRs, but also it takes all the pointers to all the other repositories for delegated RPKI. So it contacts each one of them, gets all the RPKI data, so downloads it. And when we talk about RPKI data, we talk about ROAs, we talk about certificates, we talk about keys, public keys, of course. And it uses this data, starting from the ROAs, basically, to validate all the chains of trust. So it does some sort of cryptographic work. It validates the signatures, it validates the full chain, makes sure there is always a relationship that is fulfilled between every piece of data, and then creates this local validated cache. So has a local database that contains all the ROAs, the ones that have passed all these tests, and then has a component that's a server that runs a protocol called RPKI RTR, which is used to send this data to the routers. So this is basically how it works. You have the 5 repositories, the 5, the RIPE-NCC, ARIN, APNIC, LACNIC, and Afrinic. And as you might notice, it's not that we forgot to add the green check on ARIN. The ARIN repository, the TAL file, the TAL, the Trust Anchor Locator, it's a file, I mentioned it already, that contains the location of the repositories of the RIR and the public key. All the four you see, RIPE-NCC, APNIC, LACNIC, and AFNIC, are distributed freely. ARIN has a special agreement with the organizations that maintain the validators. The ARIN TAL can be distributed, but users have to acknowledge they have read the terms and conditions to use it. That's the only difference. In the past, you had to manually go and download it and put it into your validator. Now, it's easier. And I have an example, demo in a moment, where I can show you that there is that small limitation. Okay, I see something in the chat. Okay, we have a question on IRR Explorer. What does the warning message expected route object in ARIN but only found in other IRRs really means? One of my prefixes is getting this advice, but the ROA was submitted in ARIN. I think, Tim, this is for you.
Yeah, I can answer that. It is not about ROAS in this case. It is about route objects. Your IP space is assigned or allocated to you by ARIN, but the database entry is probably made in another database like RADB or RouteDB or NTT.com, or just what you chose. And it just shows that there's a mismatch between the database that the assigned or allocated the prefix and the one you registered it in. This is specifically something which I meant with the you can have good reasons to do otherwise. This is not per se bad. It can be that you had good reasons to use another database to put that data entry in. But IRR Explorer would expect you that the most common thing is to register objects in the database that allocated you the resources. And that's basically what this is telling you. Is that clear in this way? So it has nothing to do with the ROAS you created. Yes. Okay.
So you're one of those people who use a third-party database to create route objects. There we go. Yeah. That's a great example. Thanks.
And like I said, there could be very good reasons to do so. But yeah, we can just spot it and tell you, well, you may want to consider doing it in the ARIN database, but maybe not. Okay.
So to make it clear, Renata, having the objects in RADB or ARIN doesn't make any difference when you intend to have your prefix routed by your upstreams or peers or anyone else. The suggestion from IRR Explorer, as Teun just said, is you have an official IRR from ARIN now you can use. So if possible, create the object there as well. And then one day you might want to if possible, delete the RADB object, or if you have a maintainer there and you pay the yearly fee for the maintainer, you could also at that point maybe give up the maintainer, delete your objects, and then just keep the ones in ARIN. Because don't forget that then the ARIN object gets mirrored in RADB as well. So you should see that there as well. Okay, but that's a good thing. Thanks for the answer, Teun. And I didn't spot, I have to admit, when I was reading the question, I also got puzzled the moment, and then I realized we were talking about root object and ROAS, and it was mixed. So thank you for pointing that out. Okay, so I was talking about trust anchor locators. The role of the validator is to be in the middle of it all, download the data, verify the chain of trust, and then, provide data to the router. So the router that also stands in the middle gets ROAS on one side, BGP announcements on the other, and then it can use ROAS to verify data in the BGP announcements to see if they match. And the ultimate direction, the ultimate goal is to help a router make better routing decisions, which means having additional data on top of route objects and on top of the neighbors to figure out if a network is supposed to be there or not. Well, you have different options for running validators. You have Routinator, Rust, by NL NetLabs. You have RPKI clients, that's part of the OpenBSD project written in C. You have Octo RPKI, that's from Cloudflare, and then Fort. Personally, I use Routinator and Fort. That's a good mix. I would suggest if you have OpenBSD or if you run Ubuntu, there's the portable version of RPKI client you can use there. You can try that as well. At the moment, the only one I wouldn't use or trust 100% is Octo RPKI because the person who was maintaining that at Cloudflare left, went to another. Now has another job. So there is a maintenance issue there that I would consider. The rest, Routinator, RPKI client, Fort, I would recommend each and every one of them. So how do you configure and run a validator? That's actually very, very simple. Although the suggestion is to run at least 2 validators. In this case, we have Routinator and Fort. And you have to configure the correct trust anchor locators. They've already been downloaded. The RNTAL, I mentioned it, needs to be acknowledged separately. So the way it works is that when you try to run, say, Routinator, and it seems here I've skipped a passage. I'm already trying to run Routinator. How do you install that? It's actually very simple. There are packages for each and every platform you can imagine. So I didn't go into that detail here. But this is an example of how you could run Routinator from the command line. You say run a server, run RTR on that IP address, on that port, and it tells you that you have to initialize it. And I think I remember, yeah. Well, here's the Fort initialization. So I confused it, but the concept is the same. You're told to download and read the ARIN relying party agreement from that URL. There's a PDF. It's a legal notice basically from ARIN. And once you've read it, you type yes, and then ARIN will, and then Routinator or Fort will install the trust anchor locators where you tell it to do. And then there's a passage that's it's missing. So here, when you run Routinator again with the same command line, you get to see it running, and then you should see it running here. The same goes with Fort, and yeah. Oh, okay, that's a good question. Sorry for the interruption. We set up Routinator and Fort. The number of prefixes from Fort is less than Routinator's. Did you have the same experience? I guess yes. I think, okay, this is interesting because it's something I've been checking on and off because we run a tool called Roast at ISOC, where we do a daily run checking the validity of prefixes. And of course, we have to rely on some validators. I've seen on and off issues with, we have a bunch, sorry, take a step back. We have a bunch of validators running, a mix like of Routinator and Fort. And I've had notifications that in some runs, some prefixes from some parts of the world didn't show up as valid, but they showed up as unknown, which is which might lead to what you are to similar experiences you are having. I haven't delved too much into this, but we can do it in a moment once we set up the validators on the router. It might be given by how strict the validation is being done by Fort and the routinator, or it might be given by one endpoint for the publication of the ROAs of the VRPs, of the ROAs is accessible from one install and maybe not reachable from the other. There might be different explanations. I don't know I don't have a full answer for this, but I can tell you I have seen this and it's been on and off. And so it's been a bit hard to track, but there are reports that the number of prefixes, the number of ROAs is different between the two. There might be a reason for that. It might be that you've started routinator at one point, then half an hour later you started Fort, and then there are changes in that half hour that routinator hasn't picked up yet because it's waiting for the hour to pass as a standard, how do you call it, refresh time. Or it might just be that there is something else going on in the validation. One of them does a stricter validation than others, so some objects don't pass the stricter validation. I don't have a full answer for this. I have pointers to what the issue could be. I'm sorry. Yeah, timing is also very relevant. Yeah. Yeah, so Tony is saying that timing is also very relevant, and he even sees differences between two separate RPKI client installs. So there might be multiple reasons for that, for what you see and what I have seen as well, and what Tony has seen. So as you can see, running a validator, you don't really have to change much in the configuration. The only thing you might want to change, the only thing you want to change in both Fort and routinator is maybe the IP address they're going to bind on, so that you can then reach them from another host from your routers. But that's it. And then once they start running, you don't have to touch them. You might want to monitor them, but there's not much else to change in terms of configuration. At least in all the installs I've done, I've only touched the IP address they need to bind on for the RTR server, and that's it. Haven't touched any timers or anything else. I guess Tön might confirm he's done the same. Yes, he's nodding. Okay, thanks. So now we have taken all this data, the data we have from the different RIRs. We have the validator. The validator verified the chain of trust for us. Now there's the final step. Final step is the validation. And in a moment, I'll also need to turn my light on because clouds have come here and it's too dark. But let's talk about the validation first. This is the part we've seen. We have the repositories. We have rows and certificates with either one of the two protocols, rsync or RRDP. You get the data to the validator. rsync is the usual rsync you've most likely heard already about. RRDP, and I always keep calling it RDAP, but RDAP is another protocol that's used for another thing. RRDP, based on HTTPS, publishes every once in a while the full repository and then deltas every once in a while. So to build the full repository as a validator, you ask the HTTPS in a file which one was the last full version that was published. You download that, and then at the end, basically, you have a file that tells you what's the URL for the next diff or delta, and then you walk the deltas all the way to the last one that was published. So we get all these data to the validator. The validator creates the validated cache by looking at the certificates, by looking at the keys. And then via RPKI RTR, this goes to the router. And then the router defines what's valid and what's invalid. That's the ultimate goal of RPKI. So we verify the chain of trust. We've already showed it. And this works in a way where, imagine if we have a ROA, this ROA here, that says AS100 has this 10.0.0.0/22, and it should be, this is what you should see in the routing table. So we have AS100 up there. And if we see an announcement that matches what we have in the ROA, perfect. If we have something slightly different, so in this case, AS100 creates a BGP announcement for a /24 that is more specific than that /22. We've already seen it when we were looking at the ROAs. Unfortunately, we should not accept that prefix. And the same happens when AS200 tries to announce something. The AS doesn't match the one that's in the ROA. So that BGP announcement also should show up as invalid. So how does this whole system work? Remember, we have two stages. One is ROA validation, one is BGP origin validation. In the ROA validation, we just look at the chain of trust, and then we have valid ROAs and invalid ROAs. The valid ROAs get published into the validated cache, so they get to the routers. The invalid ROAs, they don't. So when we look at BGP origin validation, we only take the data from the ROAs that are valid from a ROA validation point of view. With that in mind, we take the ROA, we get the BGP announcement, and we try to match the two. Do we, as we did in the previous slide, does the ASN match? Yes. Does the max length fit into the, does our prefix fit into the max length? Yes or no, depending on the match, full match, where the prefix becomes valid, or some mismatch, like a different ASN, a different prefix length that's not covered by the max length, then the BGP announcement becomes invalid. And those are the BGP announcements that you should be dropping. If there is no ROA, which means either the ROAs were invalid or they never got created, then the state becomes not found because we don't have a ROA, we don't have data we can match our BGP announcement with. This is the culprit of RPKI. So this scheme here is what you should just keep in mind when you look at RPKI. The three final states of a BGP announcement: valid, invalid, not found, or unknown in some cases. So, and how you get there? You get there by matching BGP announcements with what's in the ROAs. And the two things have to match. So far, so good. I can't see your faces. I can't see if you understood or if you have any doubts. So this is why I always think giving the same tutorial in person is much, much easier, because you see everyone's faces, you understand if you need to repeat something or not. But this is all to say, if you have any question, there is the chat, you can open your microphone, feel free to just jump in if anything is not clear here. Oh, I see. Oh, okay. There's a request to share the slides. Okay, not really a question, but yes, slides should be available then on the website where you registered from. I guess we can link them from the agenda. Yes. Is there any other question? I don't see you any, so we can go ahead. There is a little bit more we can check here. Imagine you are in a situation where you have a customer that complains they can't reach a website. Okay. Oh, a question about this. If you're still going to cover this, okay. Can you advise on the actual router validation when using route reflectors? Okay, I think route reflectors could do the validation themselves and avoid propagating the prefix. In that case, I have never set route reflectors up with ROV. My network is very small, but I can't see any difference in how you would treat origin validation on route reflectors. But anyway, we can get back to this. Okay, there's a nice question. Is there any research on whether step-by-step ROV causes additional delay in BGP propagation? I don't think there's a huge measurable effect. There is, of course, because you're adding an additional check on top of the BGP update process. But we're talking about a lookup in what is usually a very fast lookup table. Depending on the implementation, I know you could have a tree or a radix tree with your prefixes, with your rows. So the lookup should be very quick. In FRR, which is what I'm going to show during the demo, you see basically that ROAs represent an additional routing table with the addition of the max length. It's a special, slightly special routing table. But you see they have their own table. Same happens with BIRD, where you can check, you can verify that entries are in the routing in the ROA routing table. So you basically are just adding another routing table where you do a lookup. So they introduce a delay. I'm not sure anyone has measured it, but it's in case someone does it, I think it would be a very small delay that's introduced. So nothing that would affect your process too much. Okay. Yes, that's actually a good point from Tim. Says answering the question about route reflectors. If you run route reflectors, you would still want to do ROV, so validation on the routers at the edge of your network, so the ones receiving the prefix, so you avoid having these invalid routes being installed on your router. So that makes sense. And that's a good point I hadn't thought about when I was trying to answer the question. So thanks. Okay. Yes. I've done route servers, not route reflectors as well. And the general concept is the same as normal deployment. So thank you for validating that as well. So, but route servers, if you mean at an internet exchange, they represent an edge of a network. It's just one point, but it's the edge of the IXP, and they talk to the edge of any ISP peering at the IX. So in that case, it's slightly different from having route reflectors, which are something that's inside your network. And as Tern was saying, I would recommend not to, well, Tern was saying it, I would add my additional recommendation to not bring any invalid prefix inside your network. You can just leave them out from the edge. I see a hand up from Yasir. If you want to contribute something, feel free to open your microphone.
Hey, Max, it's Yasir. I would
Yasir, sorry.
No worries. So if you're running a two validator, let's suppose Fort and a routinator, and if you make a changes for any of the prefix, let's suppose a scenario like if that ROA update is valid for one of the validator and it is invalid for the other validator, and when the BGP, when the routers basically sync with the validated cache, so what will happen in this scenario? Because like we are getting two outputs, one is valid, one is invalid. Did you get the question?
Yes, I get it, but I can't imagine how you would build something that is valid on one validator and invalid on the other, unless you have revoked the certificate in the meantime, and one has. So
the question is basically about the synchronization, because if one validator takes maybe, let's suppose, 2 hours to sync with the database, and if other validator will take maybe more hours, like 6 or 8 hours. So what will happen in this scenario?
They don't have such a large
difference,
such a large refresh time. The default. So I've seen. I'm not sure which one of the two. One of the two has a fixed refresh. So here comes the way RPKI RTR works is that you have the router connects, and when it connects, it gets the whole dump of the whole VRPs, of the whole validated cache. Then the last, let's call it last packet, it's the last TLV it receives, contains the indication of the refresh time. That basically is telling the router, come back to me after this timeout. And it's in seconds. And I can't remember, I don't know which one of the two. So one between Fort and Routinator has a fixed one that's 3,600. The other one has a variable time that's in the hundreds of seconds. So it can be 10 minutes, so 600, it can be 700, it can be 200, and it changes. This doesn't make any difference in the end, because the router will wait for, will set up a spinning wheel that says wait for 3,600 seconds. But in the meantime, in that hour, the RTR server could still send a packet, well, a notification to the router saying, hey, there is actually a new version of the cache, because I got news from the repositories, and I have news for you. And so in that time frame, they can still get updated data. So why did I say this? It's because you never know. There isn't really such a large time frame that's hours before the validators do another run. It's we're talking about a few minutes normally, and then the validators keep checking for new data every 5 or 10 minutes from the different sources. So you never have such a long time between data refreshes. So
right.
I hope this indirectly answers your question.
Yeah, all good. Thank you. Thank you.
Yeah, you're welcome. I mean, you can manually set up the validators to do a quicker refresh, like get the data, update the data from the RIRs more often. And you could set it so that it has a manually set timeout for the routers, but I would not recommend that, because they include still mechanisms to notify that there's a new new data waiting for the router to pick it up. So there is no need to play with timers, no need to play with anything. Yes, sir. Yes. In the meantime, yes. So in the comment is, anyway, we have to accept the unknowns. So the ones where you don't have a route object. Yes. In a perfect world, the unknowns would be a very tiny percentage, because everyone would have created ROAs for covering their prefixes. But for now, the unknowns represent such a large number that we still have to accept them. In the demo, there I have actually a suggestion on how you could treat the unknowns. So far, we have looked at the data we receive from the RIRs. But imagine you have a situation where you have that /24 that is a network where there are some services that are being provided by AS100, and you have another AS somewhere else on the internet. And some customers complain they can't access that /24 because, well, you can see it. Someone made a mistake in creating the ROA, and there is no specific ROA for that /24. So that prefix for you is invalid. But you know that it's legitimate. You know that actually there are services that your users need on that /24. What can you do? There is a system called Slurm that helps you in being able to create what's called an allow list, or yes, it used to be called a whitelist. You are telling the validator to create a fake ROA inside their validated cache with specific details. This fake ROA gets sent to the router. The router then picks up a new ROA for that prefix, and that prefix magically becomes valid just for you, just for your network, not for the other networks. It's something you create internally just for yourself. Well, for the routers that rely on that specific validator. Now, my suggestion, if you use this mechanism, is to set a reminder in your calendar in a few days to remove this, see the effect, or see if someone has fixed the issue with the original network, and then hopefully delete it. Because if you leave it there, if you forget that you created an exception in your validator, then in the long run, the number of exceptions keeps growing, and then you end up with a fake small routing table inside your routers. So suggestion is you create that, make an exception, but then put it in your calendar to recheck that exception in a few days, because then you can clear it if it has been corrected, or you can send a reminder email to the network operator on the other side to say, hey, fix this issue, because otherwise my users will not be happy. So here's how we set up origin validation, an example. We go with conft router BGP with the AS number, and then the first thing we need to do is to set up the address for the validators. So we need to tell our router, pick the information from that series of validators. And the suggestion is always to have at least 2 on different hosts. Don't do like I did in this example, where they're both on the same host with operating on different ports. Then the suggestion is to create a route map with entries that match RPKI, valid, the valid state, and not found. And then here's an example. It's a very stupid thing you can do, but it can help you. You can set the local preference for the RPKI valid to 100, keep it default, but then for the not found, lower it to 80. It's not going to change much in your routing, but at least you have a sort of a tag you can check to see, was this an additional tag? You can check quickly to see if the prefix was valid or invalid, or not found. Although you can see it also when you run a series of commands. Then you apply the route map accepting, well, RPKI accept in, so on the inbound, and then you should see the prefixes that are not, sorry, let me go back, because we don't have a specific statement matching RPKI invalid. The invalid prefixes will just be discarded. This is the same configuration, but for Juniper. You set up a group for RPKI validators. You set up a session to a certain IP address, a certain port, which one is your local address. And then you do the policy statement for, again, valid. And in the next one for, well, invalid in this case, we also have that. And then last for unknown, because Juniper calls it unknown in the validation state. And then you can see here we have the accept. We have the accept for invalids as well. This is an example of bad practice, but this is so you can get an idea of how you should not be doing that. And once we have this, we are basically also, see, this is another thing that's also mentioned later. You can add communities to say to your prefixes when you accept them. And so getting back to the validator configuration is not sure if your Cisco config actually worked. I can tell you it worked because that's taken from the labs we used to run. On Juniper, you couldn't get two validators on different ports on the same host to be accepted. Well, that's good point. Those are good points for Juniper. Don't run two validators on the same host. Run them on two different hosts. So I guess that's a trick to trick you into not running two validators on the same host. And then Turn says, don't add communities. Why not? Can you explain that?
I can. I try to do it by talking. Yes, the bad thing with communities is if your validator crashes, for example, and all routes change because they change from eventually, not immediately, because you still have your cache on your router. Your routes change from valid to unknown. That would create an update message for every route in your routing table to, well, your whole IGP probably. So you would create a lot of unneeded routes updates that way. It's considered not to be the best idea.
Okay, thanks. No, that's one of the, well, actions that I've also mentioned at the end of the demo.
Okay.
That's something you could also do, but yeah, no problem.
It's a good way to do a quick verification on especially on not validating routers, but there are risks involved, so you should really consider if that's what you want. And I used to do it too, and we stopped doing it for especially this reason.
Okay, that makes sense. So now I have a demo for you. Let me get my terminal and start sharing that. Actually, I will also go through the slides quickly, and then I'll go back to them. So, oh wait. Let me stop sharing and sharing still the slides. I got a bit confused. So what we have is a situation where we have the, oh, I had corrected this, but I didn't save it. So remember that we have a ROA for AS58280 originating this /22. That's the ROA we've seen in my LAR portal. Then there is, we will see that in the labs, we have an announcement for a /24 and some other networks that are invalid. We are going to set up validators, and then with AS101, we are receiving some network announcements from AS58280. Some of them are too specific, and we will filter them out. So if I go into the lab, And here we are. This is a FRR running on some miners hardware we have. This is a virtual FRR. I have a transit, and as you can see, we have 45.129.224.0/22. We have a more specific /24 that should be invalid. Then we have some other BGP announcements that are also similar. So this one, we should not be seeing it in our lab, in our routing table. But we have to do something first. First of all, on terminal, and then we define RPKI. And then in here, we do RPKI cache. So we tell our FRR, this is our validated cache at this address 1.3.162.143.28. Port is 3323. And we have to define a preference. So we're telling this is our preferred source. Use this one. And let's put another one, 1.3.162.143 and 29 on port 8323. Preference, we set it to 2. Okay, so I finished, and I could do a show RPKI prefix table. Woo! These are all the ROAs I have in here. These are all the ROAs that have been, well, the VRPs that have been downloaded from my router, from my, validated cache. And with this, I have them in my routing table. I have them here. So if I do show IP BGP, you see what I have here. This is an additional piece of information that wasn't there earlier. So I have RPKI validation codes. So my router, as soon as I provided a data source, basically, my pointers to my validators, it started doing validation in RPKI. So I see that this prefix is valid. This one is invalid. Another one that's valid, and the others are all invalid. So this tells me that the moment I start creating my route map, let's go ahead, conf. I can do route map, and I call it RPKI in. Let's see, permit 20. So I do match RPKI not found. Voila. And let's do a set local preference 100 in this case. Let's not do 80, because then we do route map RPKI in permit 30. Then I do match RPKI valid. Then I can do set local preference 120. Let's raise the local preference for the valid routes. So, show run. If I show you what I have this route map similar to the one we saw earlier. I match not found, and I give it a local preference of 100. I match valid, and I give it a local preference of 120. I don't match invalids because I don't want to accept them. So they will just be discarded. So far, so good. Okay, so the next step, router BGP. See, I have 101 is my ASN, 100 router BGP 101. Then I need to go into the address family IPv4 unicast. Well, and then I do neighbor, and my neighbor is this 110.1.0.2. Remote, route map, RPKI in. Voila. Let's clear the BGP session. Let's do it brutally. But now, if I wait for a moment and do show IP BGP, I only have the valid networks in there. The /22 and the /24, for which I have the ROAS. And then I have local preference became 120. And above, it was just, oh, not specified, so it was 100, the default value. So far, so good. Do we have any question? Let me check the chat. I see the chat is blinking at me. Oh, Mark, configs for MikroTik version 7. I have actually a very old blog post that I did about RouterOS version 7 and RPKI. I should actually refresh that. But the concept is the same. I can go and refresh them. I just don't have a virtual machine with RouterOS running right now. But this is the concept with on how to run it with FRR. Let me stop sharing my screen and share the slides, because I've gone through this demo setup. I've configured the validators. I was following this basically. Show the RPKI prefix table, check that if it worked, checked if adding the validators brought in the additional data. And then we create a route map. And last but not least, we applied the route map to the neighbor, and then this /24 should have disappeared from our table, which was the case. So yes, this goes against what Tern just said. I see the nice discussion there. I know, Mark. We can provide more checks with MikroTik. Maybe let me see this. If you promise you'll be at the next tutorial on Wednesday, I will add MikroTik. So you'll have to be there and bring more people from South Africa, from the South African NOG. I'll see if I can add the MikroTik parts. I'll let you know on the channel there, on the Telegram channel. And Zanog discuss. So what this goes against what Tern just said. Don't bring around stuff with communities. But my initial intention was to show which one is valid and which one is not found, not bringing around the invalids with a community tagged with them. Let's see, I see you're typing. Is there any other wisdom you want to share? Yeah, for testing, this is fine. Yes, maybe it's not better. It's better not to do it on a large production network. But yes, you could do this. You could, well, I mean, if you run your own network, you could tag your routes the way you want. Maybe you want to figure out where they come from, how they were validated. There's a different way of doing that, but you can treat them the way you want. Now you can go to a website. There's if you go with your browser to this URL, you can check if the network you're on applies origin validation. Now, a question for you: how do you think this works? Because I always like to test if people were following. See you, Yasser. Okay. Would anyone like to try to explain how this system works? It's relatively simple once you figured out we have any volunteer? You can open your microphone and just try to see if you can think of a way for. Yes, good point. So there is not the web server. That's a good point, Bill. Okay, now it's broken. Okay. Anyway, the way it works is, the way it worked or will work is, you get your browser to, so you open this page with your browser. The page tries to open two different files that are hosted on two different networks. One network validates, the other one doesn't. So if your browser can fetch both files, then there is no origin validation happening on your network. If only one file can be fetched and the other can't, then it means origin validation is being applied. It's a relatively easy test to implement. You can do it in JavaScript. You can do it in any language that runs on the user's browser. Now, this is broken. I'll report it to Natalie, and hopefully we'll get this fixed. Now, wrapping up. I know we still would have an hour, but we went relatively quick. So some quick suggestions: run multiple validators, both in type and location. Don't underestimate the location. So the way I've set up my network is that, well, I run software routers. So I run BERT, and I run it on FreeBSD, which means I have access to a system, sort of a virtualization system called jails. So for every router I put, I run BERT on the operating system, on the base operating system, and then I run two jails with one validator each. So I have two different jails, two different validators per pop, basically. And then I point my BERT to different other validators and maybe other pops. Monitor them. Monitor these validators, because I've seen cases where the serial number was not increasing, and which means that the validation is stuck and you're using stale data. Monitor that the RTR port is answering. And then I mentioned it earlier. When you want to figure out what's happening with your network, you can use BGP Alerter, which is not strictly related to RPKI, but it helps you have an eye on what's happening to your prefixes in a very easy way. It's written in JavaScript, uses Node, but you can just download it. You can download a release. There's the version for macOS, there's a version for Unix, for Linux, and you can just run it from the command line. When you run it the first time, it helps you with questions in creating the config file. What's your ASN? What are the prefixes you want to monitor? Anything else? And then you can set it up to notify you on Slack, Telegram, WhatsApp, anything. No, WhatsApp, I'm not sure, but Slack, IRC, Telegram, these are all doable. Email, IRC, and then get a notification when something happens, something changes in the routing of your prefixes. How does it do that? It does it by looking at RIS data. RIS is the routing information system from RIPE-NCC, a series of root collectors spread all over the world that feed data to what's called RIS Live. Basically, you are listening on RIS Live via JSON. You're listening on network events, BGP updates happening. I'll talk a little bit more about this in the next few days. And looking at RIS data, your BGP Alerter is able to figure out if there has been any change in routing to your prefixes, and then notify you if there's anything that's suspicious. And on top of that, BGP Alerter was written by Massimo, which is a fellow Italian, so you should be using it just because of this. But we also have Manners training tutorials, manners.org/tutorials. They're a bit larger they're not just about RPKI, they are about Manners in total, in everything about Manners, how to implement it. And we have a hands-on lab that's being refreshed as we speak with more platforms, more things. But you can use this as a standalone lab or for the final exam. And then if you are willing to have a look at Manners and how you can join that. And then you can get involved in the community. So maybe amongst the 40 people that are still connected, there's someone who might speak at the next year's RPKI week. Do we have any remaining questions? I don't see the chat blinking, so I don't see any questions there. And I see we've lost people. We were at about 50 people on the tutorial, but now we are at 37. We've reached the end, so that means you'll have 50 minutes back that you can use to maybe test some more features of RPKI or to look into setting up a lab or anything. Or is there anything else you'd like to know? Do you have any remaining question? Otherwise, I will be waiting here for 5-10 minutes, and feel free to open your mic and just ask the questions. And with this, I would thank you all for being here. Having almost 40 people all the way to the end means a lot to me. So thank you for being here. And I hope you enjoyed it. And sorry about the noise outside, but you know, when you decide to, okay, let's keep the window open, kids decide to play, then I figured out, luckily when Tön was talking, that I live next to an airport, and it was the first day they reintroduced the A380 here in Zurich from what's the company, Emirates. So I actually witnessed again the A380 departing from here. So thank you very much for being here. I see a lot of thank yous, but I have to thank you. And if you have any question, my email address is there. You had the one from Tön, and thank you very much. And thank you, Tön, for being here.
You're welcome.